So welcome back to the Git version control session 2, and this course is conducted under Cisco's Incubator program along with Li2 Technologies, and I will brief about what did we cover in session 1. Session 1 was basically an introduction to Git and creating repositories in the from local machine and in the GUI, GitHub GUI. If you can see, we had created a repository and performed a couple of exercises, etc. Session 1 was very basic, and you might have already knowledge of Git basics already. But foundation is important to get started with more advanced concepts, which we will be covering in this section. So let's start. This session is about more advanced concepts of Git, like branching and working with collaboration teams, and sharing the repositories with multiple people. And also we are covering hosting a static website on Git, which Git provides, and they call it GitHub pages. So make sure that we will be performing exercise in the last of the session. Make sure you are available till the last, so it's a fun session. So let's start. So the contents for this session are, first we will be covering about what is branching, what is pull request and merging, and we will see the demo for everything, and also working with the remote and collaboration, how you can add your already existing code to different remote repositories with the same code base, and how to work in collaboration. Say you are working with your project team and you want to maintain a single code base, then working with collaboration comes into picture, and that we will learn here. And also very important concept called forking in GitHub, and also undoing the Git things which you do. Say you had pushed something, and then you want to go back to the previous version, then it's possible in GitHub. We will look into it. And as I said, we will be covering static website hosting with GitHub pages. Also, at the last, we will be performing a fun activity where we will be where you guys will be contributing to the repository, and it will be automatically hosted, and you can see the changes right there once you make the pull request. I'll guide the activity instructions later. So let's get started. First concept is branching, pull requests, and merging. So what is branching? So branching is a way to work on different versions of a repository at one time. So what does it mean? Branching means, say you have a single repository, and obviously there will be new features that you want to add on to your already existing project. Let's take an example of an app. Your company is working on an app, and they are saying we want this feature, and we want that feature too, and we want that feature too. So let's say there are like two features you have to work on. Then working on a single repository and making changes over there itself will be a tedious task, because there will be a number of developers working on the same project, and you have to be very careful about your versions that you are maintaining, and there should not be any conflicts also, which we will see later. Also, it should not downgrade the performance once everything is merged. So it's better to start a new branch, which I will explain it. And so we can just create a new branch for each feature, and each developers can work on the features which they are focusing on. So a branch represents an independent line of development. A branch serves as abstraction of edit stage commit process. So different branch name in Git is a default branch in Git is a master. In session one also, I have mentioned that the place where we are pushing our code was the master branch. That is the default branch of Git when you create a repository and add code to it. So this is the image you can see. There is a master branch and it has a repository created, and at the second point you can see there is a new branch created, and that's called a new feature. And you can say another developer is working on new feature, and once he completes the feature and it's the changes are merged back to the master branch, so that the new feature is combined into the master branch, and the production goes in proper timeline. So this is how branching works in brief. And this is one more example. And you can consider the green as master branch, and blue as your works that you are doing, and you will be branching out at some point and you will continue your work in different branch. And there is a master branch which has all the changes done by itself, and someone else want to continue in the middle, and they will create their own branch and they will start working there. And once your works are done, you can see that your works is merged in the last but one dot, and someone else is also working on the same project, so he hasn't completed task yet. So once he completes, those changes are also merged into the master branch. So what is the takeaway is, like, you can work on different branch, which is like a same clone of your master branch at the point of creating a new branch, and then just start the work in that branch. And once your task is done, you can push or you can merge all those code into the master branch. So in order to do this, there is something called a pull request. So what is a pull request? Pull request let you Pull requests let you tell others about the changes you have pushed to a branch in a repository on GitHub. Once a pull request is opened, you can discuss and review the potential changes and collaborations and add follow-up comments before your changes are merged into the master branch. So as I said, if a developer is working on a feature and he has finished it, and others will have also some suggestions and editings and some few of the concepts they want to add to the same feature. So what they can do is they can just look his code base, what he has written, what pull request he has created, and they can just commit it. They can just add their opinions right there, and they can have a track of all the changes that needs to be done, maybe in the next version, like that. So that's how the process of like merging comes. When it comes to process of merging, you have to create a pull request to merge it. So that's what it is called. When you are finished with your work in your branch, you will be making a pull request to another branch. Usually it's master branch, and your changes will be reflected in master branch. So this is again example representation. Uh, Code written by different developers are verified and merged in the main branch. As I said, they will create a pull request, and other developers will approve it, or they will commit on it, and that's how it. That's how the process takes place, and later it's merged. So it's verified and merged later, and yeah, as I said, merging, once the pull request is created, the process of like combining all those code that was created by some other user in some other branch, and this process of combining is called merging. And as you can see, this is like a sample, like snippet code, you can say, for making branching and adding some files into the new branch, and then again shifting back to master and merging the new changes. right? So we will explore everything in the demo, and this is just a code snippet that you are looking at. So there is one more thing called merge conflicts. So this is very important to keep in mind. So let's say there are two developers. One is developer A and developer B. So sometimes multiple developers may try to edit the same content. So in this time, let's say developer A and developer B are editing the same file in the same place, but the contents might be different, but both the developers are editing the same file at once in different branches. So what happens is they will not know what is happening in the other branch, and other developer will not know what is happening in the another branch. So they will create a pull request once they are done with their work to master branch. And what happens is Git identifies that there is a conflict in the file that they were working together, and we have to solve that conflict before merging, because developer whatever the developer A has done is also useful for the app to add as a new feature or something else, and whatever the developer B has also done is also matters. We can't ignore either one of those, right? So in this case we have to resolve by manually. It's called merge conflict, solving the merge conflict. You can do it in Git ID itself. Also, VS Code provides a cool thing, cool option to solve the merge conflict, which we will see here in the demo. And those two are the main methods that are very useful when it comes to merge conflict. So that's about merge conflict. And so the common commands, what are the common commands that are used to create a new branch or shift to a new branch, or let's say merge two branches? You have to remember, or you have to note down a couple of commands for it. And it's pretty easy. First, you can say Git branch. As the name says, Git branch lists all the branches that are present for the current directory. So, and it identifies on which branch you are present in. So that's about Git branch. Like the Git branch command will just list how many branches are present in your current working repository. Okay. Then to create a new branch, it's called Git branch and branch name. The branch name can be any variable, the name given to the branch. Usually it's a new feature or a bug resolve, something like that. So that later, once that issue is fixed, the changes are merged to the master branch. So one more command, it's called Git Checkout, and this command is used to shift between the branches. So let's say you have a master branch and you have a new feature branch, and if you want to switch from master branch to new feature branch, you will have to use this command, Git Checkout, and whatever the name of the branch you want to shift to. That is the syntax for it. And one more command, you can create directly new branch and then just switch to that branch. So if you do git checkout minus b and branch name, it will create a new branch if it is not there, and it will shift to that branch. So you don't have to create branch once and then check out again. So it's done in one single command. And so Git log is one of the command that is very useful when you want to check what all the changes you have made from the beginning. So we will be commenting all the changes to whatever the changes we make, right? So Git keeps track of everything, and in terms of log. So it keeps a log of all the changes that was made, and you can directly view it. And we will see it in the demo. You will understand it better. And one more thing about Git diff. and source branch and target branch. This is to compare two branches, that if there are any changes, you can compare at any point of time that is there any change in the target branch with my source branch that I'm working. So if you want to delete the branch after merging, you can use branch git branch minus d and branch name. So this basically deletes the branch once the changes or things are merged in the local repository. But in GUI, when you create a pull request and when you create merge merge, when you merge it, the new branch will automatically gets merged to the master branch, and that is deleted automatically usually. But in the local repository, it's not the case. So you will have to delete it by minus d command, hyphen d, or whatever command once it's done. So to merge two different branches, you will have to move to that specific branch, and you have to execute this command: merge git merge and merge the new branch, the name given to the new branch that you want to merge to the branch you are on right now. So that's all the commands: uh, git branch and git checkout, git log, git difference, git diff, and git merge. Yeah. So let's go ahead and do this. First, I will explain with slides, and next let's do it in demo, VS Code and GitHub. So firstly, create a pull request from branching and merging. So first, I have cloned the previously used repository. You can see in session one, this was the repository that we had used for demo purposes in the PPT. I've cloned the same repository using git clone, and the same repository is present locally. And what I'm doing now is I'm executing git master, sorry, git branch, and it is saying that I am on the master branch, right? The only branch that was present before was master branch. So it's saying you are on a master branch. You can say that it's highlighted in green. So next, what I'm doing is I'll be executing git checkout minus b and new. So what it does is it creates a new branch called new, and it switches to that branch. And if I check now, if I check the status after modifying, one second. Yeah, it will create a new branch. And once I'm switched to that branch, you can see that this was the initial README file, and I will modify the README file. And you can see here, I've written made changes in new branch, that once I have created a new branch, I have made changes in that particular branch README file. So I have made changes and I have saved it. So when I run git status, git should understand that I have made change, and in order to like add it to staged area, I will have to commit it. So I will be committing it, and this is one more shortcut you can say. Once you have all the files in your staged repository, you won't have to execute git add dot and git commit and then git push. You can just go ahead with git commit minus am. A stands for add and m stands for message here, so that it will execute both the steps in one single command. This is one major takeaway you can say, and you can execute and upload uh, the files directly with one command. So here I have mentioned that I have just updated the README file, and this is taking place in the new branch. So what I'm doing now is I'm pushing this code to GitHub, and in order to do that, I will have to set the origin for it. Before, if you had remembered, when we created a new repository, we had to add git push minus u master origin. Here also, we will be setting minus u. Minus u is as set upstream, and we will be saying that this is the origin in the new branch. But this is not pushed to master branch. This is pushed to completely new branch called new. So once we push the code, you can see the changes in the GitHub that this branch has already appeared as a new branch under branch when you visit your repository. I hope this is clear once you create new branch and you will be pushing it to the GitHub. So next you can see that second line which we added also is here, which we had added it in the new branch, and that changes are reflected here, right? So next, in order to merge, as I said, the process of merging is called creating a pull request and then merging. And process of creating a pull request is done by this clicking this option called new pull request. Actually, when you create a new branch, it will only suggest you to create a pull request. You can see that below this red box, there is a line called this branch is one commit ahead of master. So it's asking us to compare, or it's asking us to create a pull request, right? So it is suggested by GitHub automatically. And you can just go ahead and create pull request by pressing the new pull request button, which we will see in the demo, and you will understand it. And once you create pull request, it asks you that what is this pull request for, what was the thing that was updated in this branch, and you will have to write a brief commit for it and then create a pull request. So once the pull request is created, uh, it's able to merge into master, and Git will identify if there are any conflicts. We will explore that also. And so once the pull request is created, it's able to merge into master. So if you go ahead and click on merge pull request, the pull request that was created will be merged to master branch. And you can see here the colors, and green is like open pull request, and once it is merged, it becomes purple, and it says the branch is already merged. So once it is merged, you can just delete the branch here. Even this gives option to delete the branch, and you can go ahead and delete it if it is of no use anymore. So that's how a pull request works. Basically, here we have created new branch in local repository and then pushed it to GitHub, and then created a pull request in GitHub itself and then merged the changes. So next, let's talk about merge conflicts. And before that, I think we can go ahead and explore about the branching commands that I just explained. So it will be more clear when we start with merge conflicts. So I will create a new directory. I'm calling it as session 2. Yeah, so I am inside session 2 directory, and here let's create new files. I will close the old files. I will create a new file called, or let's do one thing. Let's create a repository online and clone it. That would be better. So one more thing, we will be covering all more details like working with collaboration and all those things in later section. So right now I have created an organization for this workshop under TQB Li2. GitHub, and I have named it as TQBLI2. I will show you about organization and working with collaboration in the next upcoming slides. For now, I will create repository under this. So repository name will be session 2, and I'm making it as public directory. So by default, it was saying private, right? Because when you are working in an organization, usually the private repositories are more. Usually the private repositories what they prefer. So by default, it's private. So I will go ahead and initialize with README file, and I will create a repository. So repository is created, and description is optional. I'll just say this was for merge example. So let's clone the repository. I will use HTTPS. Going back to VS Code. I'm cloning the session 2, and it's under session 2 now. So I have to move into the repository that I cloned. And if I run git status, there is nothing new. It's up to date, right? So it's directly cloned from GitHub. So it's perfectly all right. So next, let's modify this README file a bit. Session 2, and this is master branch. Okay. So what I'm doing now is I'll just push all my changes that I did just now, that I added one more line in readme.md file, right? I'll just push all the changes. So as I said, you don't have to git add dot and then again git commit. You can just go ahead with git commit my -am updated readme.md. You can see that the file is committed, and if I git push, it asks me for the password because SSH setup. Yeah, so the changes should reflect online. Yeah, you can see the changes. This is a master branch. You can see here, branch, master branch, and this is session 2 repository, correct? And let's go ahead and create new branch. So if you remember the command, it was git checkout -b for branch, and I'm calling it new branch. Okay, yeah. It says I'm switched to new branch. If I list all my branches, yeah, you can see that green is highlighted because I am in the new branch now. So if I want to move to master, then I can just move to master by git checkout master. So it's switched to master. And if you again say git branch, you can see that master is green now. And you can see the star. This is like a pointer where which shows that which branch you are currently on. I'll clear again. I'll move back to new branch that was created. So I'm in the new branch now. Yeah, I'm in the new branch. I will clear my terminal, and let's go ahead and changes in this particular branch. So what I'm going to do is there is only one file called readme.md here, right? So I'm going to create one more file. I will use touch command for it, and I'm calling it info.txt. Let's create a txt, and you should see here that text file is created, and I am adding few contents here. This file is created from new branch. So if I run git status now, it will say there is a file that is not tracked by Git, and I have to add it from the first command itself. I can't use git add, git commit hyphen am for this, because this was not tracked by Git previously, right? So I will have to add by adding git add and git commit minus m new. I will just say created info.txt. So this is committed, and I will be pushing these changes to branch itself. Okay, and I will just git push. Yeah, I can't git push it for the first time, right? So as I said in the PPT, I have to use this command to say git that this is my upstream, this is like minus u, and once I use this command, from next time I can use git push. So over here I'm using git push by hyphen set upstream. Instead of this, we can also use minus u, okay, and origin and its new branch, correct? And if I hit enter, ask me for the password. So the new branch is successfully pushed to the repository, and we can go to repository that we had, and we can refresh, and you can see here new branch less than a minute ago that was pushed, and it will reflect to here. You can see the changes here, and you can switch to new branch, and you can see that info.txt was created in that branch, and it's here. So that's how branching works. You have to create new branch and you will have to push. And let's now see how to merge those changes into the master branch. So output, what I'm expecting is this info.txt should be on my master branch that was previously there, right? So GitHub is telling me you can compare and pull request, create a pull request. So I will just click that button, and it has already compared that base branch, which is my master branch, and comparison branch was new branch. And it's saying with the arrow mark, you can see here that comparing this branch with the master branch, and it's able to merge. So I can just now comment that I have created info.txt in the new branch, and that was the change I made, and it's already there. So I will just create a pull request. So the pull request is created. So once the pull request is created, you can add uh, commit to it, and other developers will have a look into the pull request you have made, and they can also commit to the pull request that was created, and it can be very useful when it was uh, when you are debugging or something, when the bug is resolved or something. If the project is open source, you can just fork that project, and you can resolve that issue, and you can create a pull request to that project, and if the author or admin likes your issue resolving code, and he will just merge your code, correct? So I can press on merge now. So I will have to specify that this was merged with the new branch, and this is the message, and this is the description that we are adding, and it will ask me for the email account, because when you are working with different developers, different actions will be performed by different people. So we have successfully merged the branch that was created, and you will see that we are on master branch and there is info.txt. So what we just did was we just merged this new branch changes to master branch, correct? That's how merging works. Hope this is clear. This is very important concept, and you will be using this very frequently when you're working with a team or a couple of your friends in a project, in a hackathon, like that. So next, coming to merge conflicts, let's see how what does merge conflict mean and how merge conflict actually happen. And I've shown an example here in the PPT. Let's consider again, there are two branches. One is master branch and one is a sub branch. So what is happening now is in the master branch, developer is adding his line. I have added p tag. You can see below happy learning, there is added from master branch. And in the sub branch, one more developer is adding one more line in the same place. You can see the line number, that is 12, and here also that is 12. So these two are different branches, but they are editing in the same place without even like knowing, because they won't get to know about the other branch status, right, when they are working isolated in an isolated branch. So they have edited the file and they have pushed the changes as we did to the repository. So now all the changes that was made in the master branch and all the changes that was made in the sub branch, both are present in GitHub. So once the all the code is present on the GitHub, obviously Git will notify if it is able to merge, or else we will have to create a pull request by manually. You can see this button over here, right? New pull request, which we had seen. Then we will have to click on that button. And right now you can see here when it is comparing, it's not suggesting us to or it's saying that it can't merge automatically, but we will have to resolve it by manual process, and then it will understand and it will merge changes later. So right now what is happening is it's comparing this new branch conflict example I have taken, and it's comparing with the master branch, and there is a conflict, and it's saying it can't merge automatically, but still you can create a pull request and there is a method to resolve it. So let's go ahead and create a pull request, and the pull request is successfully created, but again it will notify that this branch has conflict and that must be resolved, correct? Without this resolving the conflict that had taken place, it's not possible to merge. So you can see that merge pull request button is disabled and the color is gray. That means you need to fix this manually in order to in order to merge the changes. So when you click on resolve conflict here, you will be taken to an IDE where it will show exactly where there is a conflict. So you can see that there are greater than and less than arrows and also equal to. And what this is doing is it's comparing the conflict example branch with the master branch, right? So it is telling that the whatever the contents that are present in between that equal to and less than symbol, there are like 6 to 7 less than symbols. You can consider that as an arrow mark. And between that, whatever the lines are there, those were written in conflict example branch. And whatever the line is there after that, equal to and greater than arrow mark symbols, uh, that is written in master branch. So you need to fix that manually. So in Git IDE, actually you will have to fix this manually by removing all this arrow marks and plus signs. But we will see merge conflict resolving in VS Code. It will suggest us actually to keep both the changes, or keep the first change, keep the second change that was made in this branch, like that. We will look into it. So that's how issue should be resolved. And as I said, you have to do it manually. If you want to keep both, you will have to keep remove you will have to remove all those arrow marks, and you will have to keep those two lines if you want to keep both the lines. So you will have to do it manually. And then once that is done, you can just click on mark as resolved in this corner. And when you mark as resolved, and it will save the file, and this is the final file now. And you can commit these changes that you have fixed the conflicts or something like that. Once this is done, it becomes green, and it's now the same process which we followed in the previous merge PPT content, right? So it's the same process now. It has become green, and it's saying it's an open pull request, and you can go ahead and merge the changes, right? So once you click on merge pull request, it will just merge it. So merging will take place, and it's reflected in the master branch. So let's demo about merge conflicts. So we have to be very careful about merge conflicts. So let's go ahead and do it. So right now, if I get branch, I am in the new branch, correct? So let me just switch to master branch. And right now I am in the master branch, correct? And if I run git status, your branch is up to date. It is saying working tree is clean. But if there are any changes made online and the changes won't be here, in order to fix that, you will have to run git pull, because I had merged the info.txt online, and my local machine was not aware of that merge. And right now I have executed git pull, and that info.txt, which was in the new branch and which was merged to master branch, is also there on my local repository. So if I do let's clear the terminal. Let me run Git log for now, and you can see that, as I said, Git will keep track of all the changes that we are making, and this is the changes that we have made so far. You can see that initially that readme.md file was created and it was updated, and I had created in info.txt. And then again while adding pull request, we added this as a comment. And then while merging the two repositories, we added the commit, and it's showing and storing everything that we are making, that the changes, correct? And you can see that it has a hash value, where it will understand that this particular comment is of this ID, or you can say that this is the name that is understood by GitHub, and human beings cannot read this. So In order to understand for us, we have a message or commit option. That's why we commit all the changes that we are making. That's why the message feature exists. Otherwise, it's of no use if we could just read this hash value. So that's why the message exists. But Git won't keep like Git won't understand the message that we had written manually. It's for our reference. It will keep track of all the changes that we are making in its own way by generating hashes and pointers. Also, one more thing, there is something called a head pointer, and it will be always pointing to the latest commit that you had made. So right now we are in the master branch. It's pointing to the master branch, and it's also saying that this is the last commit that was made, and that's why the head pointer is here. So if I make any change and then again go back to Git log, then it will add that new commit, and head pointer will be present over there. So let's quickly exit this. You will have to press Q to exit, and let me clear. Yeah. So we were about to create a new branch and create a conflict, and we were about to merge it, correct? So I am in the master branch, Git branch. You can see that I am in the master branch. So let me create one more branch. I will call it conflict example, correct? And I've been switched to conflict example branch, you can see. And over here, let's modify, or let's create one more line here in, and let's say that this is modified from conflict example branch. Okay, then you can check the git status. It will say that info.txt was modified in order to to add it to the staged area. You have to add a commit, and it suggests us to add git add and then commit. So what I'm doing right now, I will just clear again and I will add commit. I'm taking advantage of this command, and it will, as I said, it will add and it will modify at the same time. I will just say modified from modified info.txt, correct? I have commented it. So this time I am not pushing the code to GitHub. Before that, I will try to merge and I will try to resolve the merge conflict in the VS Code itself, because we have seen the merge conflict solving method in the PPT in GitHub IDE, right? So that's sufficient, I guess. So this is very important. Also, this is very easy also in VS Code to resolve the merge conflict. I can just move back to my Git master, Git checkout master. I'm switched to master branch now. If I git branch, I am in the master branch. Also, I will clear my terminal. And right now, you can see that the second line which was present there is not here, because that's completely a different branch, right? So let's go ahead and add the same line in the same place that we had made changes in that particular file. So what I'm going to do now is I will add conflict line. Okay. Also, if you are observing, my VS Code is keeping track of all the files that I'm modifying and all the files I'm creating, and even the Git, like whatever the staged area has, all those things. So here you can see that it's written M for info.txt and it's in orange, slight yellowish, you can say, and that means that this file was modified but not added to the staged area of GitHub. So if you want to roll back to the change that we had made, we will be exploring with the commands in later section. But as of now, you can go ahead to this and it will have all the changes and you can just undo it from here. You can see that session 2, in session 2 we have modified this info.txt, so I can just undo it and I can stage the changes here itself, like that. VS Code is pretty good for using GitHub, also GitHub, instead of like it will understand by itself, and it's pretty useful when we are working in hundreds of files, and it will have all the list of files that we just changed, so that it will be useful to undo the files right here, correct? And also one more thing, if you notice in the left bottom corner there is a branch name, it says master. So it does mean that I am in a master branch right now and I have modified some changes. So if I click on this, it will show all the available branches. So this is my master branch and this is the new branch that I created previously, and we had merged this branch. I have not deleted it, that's why it's there. And origin master is the same, and this is origin head and origin new branch, all these things. So all the origin slash master, all these things are present in the GitHub repository, correct? And this conflict example and master branch are not present in the remote repository yet. We need to add it, correct? So that's where that's the difference. That's why it's repeated. And this is local, and this is last three are remote. And we will explore about remote command in the later section also. It's also very important to know about remote command. So right now we were here creating conflict, and right now if I git diff master conflict, did I misspell? Okay, so Git doesn't know about my branch yet, but I can compare my master with another branch, new branch, which is already known to Git. It won't give me any error or any output because there is no difference between master branch and new branch for now, because we have already merged it. I just wanted to execute git diff. Uh, so let's merge the branch. Git merge. I am in the master branch. Okay, I did not commit the changes. That's why the diff wasn't working. Git commit. So I have committed it, and you can see that this orange, yellow thing, yellow highlighting thing is gone now because it's in the staged area. So my working tree is clean. So right now, if I want to, merge it, git merge and the conflict branch. Okay, maybe it's a typing error. Okay, I have missed A in the name. Sorry for that. Yeah, thanks for informing Tribhuvan. Yeah, so that was a typing error. That was the error that we were getting. Git branch. I'm in the master branch now. Git merge conflict without A. And now it should inform me that there is a conflict which is present in your both the branches. One is master branch and one is another conflict example branch which we had created. So you can see this nice UI provided by VS Code to fix the merge conflicts, correct? So what you can do now is you can accept the current change and you can go ahead, or else you can just accept incoming change, that is this branch, and you can go ahead, or accept both the changes that took place in both the files. As I said, if both the developers are working in two different files, it can be fixed and it can be merged properly by accepting both the changes. Or if it is a very large file, then you will have to compare both of the files and then do the conflict resolving thing by comparing the changes and what are the lines. If there are like 1,000 lines of code, you will have to choose that option, which will again open two windows and it will show each line that here is the difference, here is the conflict that you want to resolve. So I'll just close this for now. And this is the most useful thing that you could use in VS Code while merging or while resolving the conflict. So you will have to just say git merge and conflict, whatever the branch name is, and you can accept both the changes if that is the case, and if you can ignore any one of them if that is the case, correct? So right now I have accepted both the changes and I will be saving this file. I saved this file, and now if I run get status, it will say that there is one untracked file called info.txt and it is modified. And for this, what I will have to do is I will have to either add commit and push it to GitHub, or else I can undo the merge itself. if conflicts run, you may have like unmigrated the path. It's saying like there are a couple of different options to undo, which we will see later again. And for now, I will just git add, git commit, merge, and I will git push. So it is asking me for the password. Yeah, the changes should reflect online, correct? So this is how we fixed our merge conflict in the VS Code itself. We were getting a couple of errors here. That was because of typing mistake. I had not taken A here, but command should work fine. Those are the commands which we use. So right now we have merged the changes. If you can see the Git log, as I said, Git will keep track of all the logs. You can see that there is one more commit that was previously made, that is merge, that we did just now, correct? So I will quit this and let's move on to the IDE and yeah, let's move on to GitHub. If I refresh, you can see that my latest commit is merged, that's 1 minute ago. And you can go to this commit section and you can see, correct, it is merged. And you can visit this commit actually and then see what was the changes that was made, correct? And this is the presentation given by GitHub itself, correct? It will identify by green if it is added, and it will identify in red line if it is removed. So this is very useful while comparing the codes. When you are comparing 100 lines of codes, you can't do it in by comparing it in proper windows and two windows, etc. like that. You will need some color representation, something like that, which is very useful in this case, correct? So that's how we merged it, and I think this concept is clear, and it's very important to know about merging, making a pull request, and when there is conflict, what you have to do in order to merge it, correct? So that's about merging, and we have covered branching, pull requests, and merging. Next, let's move on to the next topic called Git Stash. So this concept is actually a pretty advanced topic, you can say, in Git. What happens in Git Stash? So what is Git Stash? What is its use? So you can consider Git Stash is a temporary space where the changes you have made in your working directory copy, so you can work on something else, and then come back to the apply them later. So I will give you an example for this where Git Stash will be helpful. Let's say you are working on some feature on your app, web or app development, and suddenly someone says, just keep that for now, that's not our priority task, and pause that, and please shift to another task on the same site, and please complete that first. So, if you want to push all the changes that you have incompleted to GitHub, other developers might confuse with the feature that was pushed, right? Because it's incomplete and it's in halfway, and it's confusing to others. So, in this case, what you can do is you can make use of Git stash, and you can store it in a place which is actually stored locally, and it's also kept track by Git, and you can just go ahead and execute Git stash, and whatever the changes that was incomplete will be stored safely, and then you can start working on your new feature that was the priority for the time. And then once that priority task is done, once the changes are pushed back to the GitHub repository, you can again come back and you can again retrieve back what we were working on and what was incomplete, and you can retrieve that by stash apply. We will see the three commands, basic commands, and we can apply it. So stashing is handy if you need to quick switch a contest on and working on something else, but you are midway to code change and quick ready to commit. Correct. As I explained, if it is halfway done and you don't want to commit, and you can just store it in stash and you can resolve that later. Also, git stash I have put right after merge conflicts because git stash is also one of the method to resolve merge conflict. Let's say you know that someone has already made changes in master branch, and if you have been working on the same file, and you know that there will be a conflict, and you are not eligible or you don't know what to keep and what to not at that stage, and you can't resolve the merge conflict, but still you want to push your updates to the same repository. Then what you can do is, so wherever there is a conflict, you can identify by yourself, like the file you will get to know, right? And then you can store it in a stash for now, and then push the changes that has to be pushed to the repository, and then later you can get back to that halfway file that you wanted to not to push, and you can complete that task, so that there will be no conflict. You don't have to deal with merge conflict, resolving merge conflict. Correct. Yeah, that's one of the method. And as for the commands, it's git stash. It will save all the newly created or the modified files in a stashed place. And when you git stash list, it will list all the stashes you have in your git tracking. And then when you are done with the task and you want to retrieve back everything, then it's git stash apply, and you will have all the changes back. So let's consider an example in the slides itself. So initially, I'm creating a file called new.txt, and I am adding it to Git tracking. And you can see that when I execute list all the directories or files that are present, it is saying readme.md file and the new.txt file. There are two files. So when I run git status, since I had created a new.txt recently, Git is saying you can in the staged area. If it is green, we all know that it's in the staged area, correct? But what if I don't want to push this new.txt for now, but I can store it in a stash, right? If I don't want to push it, I can store it in a stash. So I will just execute git stash. So what it does is whatever the things that were present on the working directory, you can see that there was only one file called new.txt in our working directory, sorry, staged area. Then the staged area contents will be put to stash, and you can come back to that anytime. And if I do, you can see that there is only readme.md file and new.txt file is gone because it's stored in stash, and you can retrieve that later. So now again, if I run git status, even that file isn't identified by git tracking. It's stored in the stash and Git won't have track of it. You can consider this as a Git ignore also. We have explored about Git ignore file, right? It's same as putting your file in the Git ignore file. So, but the problem with Git ignore file is you can't keep track of all the changes you're making, correct? It's just a file with a name .git ignore, and only GitHub will identify it. If you want to make any changes to it, it's not like identified. So it's not a good practice. If you want to ignore something, but you want to retrieve it later and work on, to add it to git ignore file is not a good practice. Using this git stash is a must, and it's correct method. It's pretty advanced, but it's useful. So once you want to retrieve back, you will have to just run stash apply, and that new file which was stored in a place is retrieved back, and you can see that new file is back in the staged area. If I list my present files that are in the current working directory, then it's two files, and new.txt is back again. So git stash apply will retrieve the top element of the stash. You can consider stash as a stack. Actually, there are a couple of other commands called git pop, git stash pop. You can explore about that, but these three are the commands that are basic and useful, and I think this should be sufficient for now. And let's come to the exciting part, and it's working with remote and collaboration. So when you are working with multiple people on the same project, and you can apply this. So as I said, there is something called Git remote. If you remember, we had already used this command when we were creating a new repository. GitHub had suggested us in the last but second line in the first block. You can see that it's git remote add origin. So what is this command saying is you are adding a remote repository that is located on the GitHub server, and it's already there. So you are adding that remote link to your local repository that is placed, so that it will identify that it has to go to this particular URL or particular place when you push any changes or when you pull any changes that you want to retrieve from the server. So git remote is to link your local repository to the remotely hosted repository that is present. So coming back to the commands, git remote helps us to manage connections and remote repositories, as I said. And let's see the commands. Git remote and git remote minus v and git remote add. This is the URL if you want to add one more sub remote directory to the same local directory that is present. So basically git remote minus v will list all the remote repositories that are linked with current directory that you are working. We will see this in terminal, and we'll get to know about it. Also, you can rename the Git remote that you have added. Let's say you have added Git remote as origin. As you can see here, you are adding Git remote add origin. Origin is a name given to a remote URL that you are placing. You can rename that later also. You want to rename it, you can rename origin to second origin or something like that. You can rename the name that is given to some remote name URL. Correct. So this is the remote suggested by GitHub when we created new repository. Just to recall it, I have put this image here. So as I said, git remote minus v will list all the origins or remote links that are linked with your local repository, correct? And let's go ahead and add some remotes. What did I here I have added a second origin. Actually, my current repository is, you can see here, examples GUI in the green. That's my present working directory. And there is already a origin that is example hyphen GUI. This is already a present remote URL. But I am adding URL to the same directory. In this case, I am doing git remote add second origin and the URL. And URL, you can see that the new repository name is new repo. So you can consider that there are two remote URLs, and you can push it to any of the repositories from the same place. So initially I have to set upstream and I have to push it to second origin directory master. So this is completely a new directory that was created, this second origin, and I have pushed the same code which was for example GUI to the second origin directory, which is example, which is new repo, correct? If I list Git remote that is associated with my current directory now, you can see there are two origins and two second origins. One is for push and one is for fetch, correct? So what is fetch here is same as pull. When we execute git pull, it will actually fetch the files that are updated from the server, right? So git fetch is also a command actually, and it's used when you want to add some more reference to your pulled command. When there are multiple branches, if there are any links between them, then this git fetch command is used. Usually we use git pull, and even git fetch is useful when you're working on a huge repository. And what if you want to remove that origin, remove that origin, second origin that you have added? Then you can just go ahead and execute this git remote and remove the name of the origin that was given to that. So if I remove the second origin is gone. When I list it, it's not there. So that's how it works. Git remote. Even you can create Git remotes for the deployment. I will give you an best example. When you are working with any deployment application, you will have to set up something called a CI/CD, that is continuous integration and continuous development. So how the process goes is you will have a repository for your development, and you will be pushing everything to that development repository when you make changes immediately. So the deployment should take place immediately. Otherwise, you will have to do it manually, right? So what you can do is you can have two origins, sub origin and a main origin, and sub origin will be for deployment and main origin will be for some GitHub repository. And if you want to push the code to deployment server, you can just go ahead and push it. And if you want to push it to the actual repository that is on GitHub, then you can push it to the GitHub repository. The best example would be if you have worked with Heroku. Heroku is like a hosting platform like AWS and all. So even it has version control on its machine, and you will have to link GitHub, and it's almost similar. So explore about it. As I said, apply for GitHub Student Developer Pack. Heroku will come with some credits also. You can experiment and explore the Heroku. So it's pretty useful. So that's where a Git remote is useful for, correct? And next, let's move on to sharing a repository when you are collaborating with multiple people. If you want to share your repository, then you can just share your current repository that you are working on with another collaborator. So let's go ahead and do it. As you can see here under TQB Li2, there is session 2. And if I go to contributors, you can see that I have committed the changes here. So it's saying I'm the contributor, I'm the only one contributor to this. So if I go to settings and if I go to manage access, and here it asks me for the password because it's main operation that is taking place on a repository, correct? So after entering the password, you can invite any people that you want to work with or team up with by their username, and you can just send an invite and they get an email. So and they will be added as a collaborator to the repository. So it's pretty useful, and when you are working with teams, you should collaborate and you should managers, and you should manage the work accordingly. That's how you add a collaborator to your repository, and these are the steps. As we experimented, we went to settings and particular repository, then we added then we went to manage access, and then we can invite the collaborator that we want to with their username. You will have to ask for their username, and the drop down will appear, and you will have to just send them invite, and they will get a link, and just they can just join. So let's come to organization part. So let's say you're working in a company and there are many people. You cannot you cannot you can only keep track of one repository and multiple people, right? What if other people also want to see all the repositories that are present? So in this case, organization plays a very important role. So organizations are shared accounts where businesses and open source projects can collaborate along with many projects once. Owners and administration can manage member access to organizations' data and projects with sophisticated security and administrative features. There are a couple of options for the admin. They can manage the roles for the members that are there. So it's pretty useful. So how to create an organization? Uh, Step one will be going to the plus icon that is there in the top right corner, and then just go ahead and create a new organization. Then it will ask you for the plan. Join for free would be fine, because that should be sufficient when you're working in a small team, and for your projects it's more than enough. It will ask for the name of the organization and the contact email, and those are the mandatory fields, and you have to fill, and then just go ahead and press next. So next you can just invite people from here itself if you know the username. Otherwise, what you have to do is you can skip this step and you can go ahead and invite them later, which is here. When you create an organization, it looks something like this. So they can see who are the people they are there in that particular organization. Also, they can see what are the repositories under this. I will just show you in a while that how it looks actually. Then they can invite, and that's how an organization works. So let's move on to the next slide. Yeah, as I said, organization members can be managed with different roles and invite. So that's about organization. So let's move on to the demo of organization. If you can observe that I am actually in an organization that I have created. It's called the Incubator Git Webex Workshop, and we will be performing an activity shortly in this organization itself. So you can add all the description, even profile pictures, all those things to maintain the code base and at one place. So all the people who are here will be able to see what are the repositories that are there, what are the changes that are taking place in the current organization, like that. So that's about organization. This is how it looks like. You can create new repository. It's the same process like how we did in our local repositories, our profile repositories, correct? So next would be a very important topic called forking in Git. So let's start with this concept. So what is forking? A fork is a copy of repository. Forking is a process where you are just copying the someone else's repository to your profile. So let's say, and it's an open source project and you want to contribute, you will have to visit their profile and you will have to visit that repository, and there is an option to fork. And when you fork it, the same repository, the exact same repository will be copied to your profile name, like you under your profile. like URL will be under your profile. So you can just modify and tweak whatever you want. You can modify all the files and you can add more things to it, and you can use it for something else. Or even if you find that is useful feature that on an already existing open source project which you had forked should have, then you can create a pull request to that particular project. And as I mentioned in earlier times also, if the author or if the admin who is managing that open source project likes it, he will approve it. And that's how you contribute to open source actually. You will have to fork the repository, and then you will have to again make a pull request, correct? So most commonly forks are used to either purpose changes or to someone else's project, or to use someone else's project as a starting point of your own idea. Uh, so a great example of using fork to purpose changes is to bug fixes, correct? If you find any bug in an open source app or open source project you're using, you can just fix it by yourself. You can just fork it and then make a fix and then submit a pull request saying that you have fixed this bug, and they will accept the pull request. So that's how you can fix the bug which is there in the open source project remotely that you are using. So how do you fork it? How do you fork the repository, correct? So once you visit the repository that you want to fork, you will see an option at the top right saying fork, or there are three options in that. Fork is the option that we will be clicking on. So you can just press on fork and you can see that the actual project is under my username and slash build an application server. And I was forking it from li to GitHub account. So it has forked the same exact project under li2 hub slash build an application server. So the same clone is present under li2 hub username. So hence I can just start working here and I can modify, correct? I can modify and then the changes will be reflected here. I can use this as my starting point for my project or something like that. So let's come to undoing in Git. Before that, I think let's just fork the repository that I had created in session one so that it will be more clear for you. Let's go ahead and go to repositories, and this was the solution that was pushed to while demoing, while solving the exercise one, correct? So I can just fork this repository to the TQB organization that I have created. You can see that I can select multiple accounts that I'm logged in, and I can just fork the repository that I want to fork. So previously it was here, and now if you can see, it's under our organization. You can just visit here, and you can change your organization to TQBLI2, and you will see all the repositories that are present when you press on view organization, correct? So this is the exercise that I forked from the repository that is already there, correct? So this is the repository that is forked now. That was a demo for forking. It's pretty easy, right? One button, it's just done. And next, let's move on to undoing in Git. So there are a couple of times where you want to undo changes, where you want to roll back to previous versions, correct? Where you want to not like when there is a bug after implementation of new feature, you will have to roll back to the previous version to fix the new bug that was found. So you can do that with undoing. And in Git, it's not an undo button or something. which is there in the traditional software and traditional systems. Instead of that, we will have a couple of commands which we have to make use of. They are git revert, git rm to remove, and git reset, and so on. So next would be looking at all the common commands that we will use to undo it. So we have executed this command already, git log. But if you want to see it in a one line, then you can just use this one line, my hyphen hyphen one line, and it will display in an understandable way. So git restore is used when you commit something, and before staging, if you want to undo it, and if you want to restore whatever you have done, and you want to remove it from the git tracking, then git restore command is used. And to undo changes and modify which reference the branch you are on points to, then you can use git reset and hash value, or latest hash value is retrieved by this at the top pointer, you can say head pointer. So also you can retrieve git you execute this command called git retrieve, and git reset and git retrieve actually performs the same operation, but there is one difference, that git reset actually rolls back to the previous commit, but git revert will actually make a new commit, and previous commits are also there, but changes are taken place. Changes will take place in both the commands, but git revert will actually make a new commit and make changes. So it's also suggested to use git reset when you are working locally, because undoing all those things, how much ever possible, should be done locally before pushing the code itself. And next, let's move on to the demo part. Uh, Initially, let's display all the log for the current that I am in, and I have created a new file called touch readme.md, and if I see the git status, it says git readme.md was created, but it's not tracked by git. So what I can do now is I can just git add readme.md, and it's brought to my staging area, correct? And what if I want to undo this? What if I want to roll back to this previous stage where it was not tracked and it was just created? So I will just execute git restore minus minus staged readme.md, correct? And you can actually see here, use GitHub is suggesting us use git restore staged file to unstaged, correct? So whatever was staged will be unstaged, and we can roll back to the this stage, and Git will not have track of readme.md file. And again, I will add this readme.md file. Again, before I had not committed it, I had just added it into staged area, and I had pressed undo. So what if you want to commit it, and then you realize that this changes is not worth it, and I have to roll back? Then what you have to do? Then you will have to execute a command called git reset. Git reset, and head one will actually point to the latest commit that you had made, and it will roll back to the previous commit. You can see here, when I did git log, there were two commits. One was added file initially, and added readme.md that I created recently. Then when I executed git reset, had one, and then it rolled back to the previous change, and it removed that commit actually. Then it removed it, and if I run git status, and readme.md is not tracked by anything. So it is removed from the commit, it is removed from the staged area. So that's where git reset comes into play. Let's come to static website hosting with GitHub pages. So how it is done is there is an option under GitHub where you can host your static files like HTML, CSS, JavaScript, and create a website out of it. Same as .html files which you create on your local machine and experiment around it. You can just host that file under your profile name, If it is a portfolio, you have to use some specific format for it. I have instructions in the upcoming PPT slides. So about GitHub pages is it's for hosting static websites. So there are three types. For each project, you can have a hosted page, or each user you can have a hosted page, or each organization can also have a hosted page. So the URLs will be slightly different. For users, it is one format. There will be no slash something from slash and etc. It will be just root domain, and it will be usually in the form of username.github.io. If you can notice some open source documentations, usually they are hosted on GitHub with the extension .io, .github.io. So those are the GitHub pages which they have hosted online for free, actually. But there is a limit to make some builds per hour and builds for upload things, and there are size limits also. But for hosting a portfolio or some sample static page of an information about your profile or about your project or about your project product, then it's useful. So as I said, there are three types, and these will be the format. If you are a user, then it will be user.github.io, and organization.github.io, etc. If you are using any repository and making it into a GitHub page, then it will be organization and username something and .github.io, then slash, then your repository name. Let's say this session 2 or exercise 1 repository, right? It has index.html file, correct? And this file can be hosted. Actually, if we host this, our URL will be there is a default URL for this which I've already hosted, and then slash exercise 1 will be my URL. We'll do it in a short period right away. So that's how URL will look like. And also you can link your GitHub pages with domains which you have already purchased. Let's say you have purchased your name.in or your name.com. Then you can link your domain name static hosted web page that is on the GitHub. So there is something called CNAME file which is created by GitHub, and I will display it in a while. And you can host and link your domains with GitHub pages. So what are the steps to create GitHub pages? You will have to create a new repository, obviously. Then if you want to create your own portfolio or your name, username.github.io website, then you will have to use this particular format for your repository name. It should be username.github.io. In this case, I'm using TQB team as my username because that is my username for the organization previously. So I have used the same name .github.io, and I have created a repository, and I have pushed a random HTML file to this repository that I just created. You can see here there are two files. One is new file.js and index.html file. And whatever the contents that are there in the index.html file will be hosted. So where is the GitHub hosting page option? So we will have to head on to settings. You can see here it's highlighted, and you have to scroll down and find for GitHub pages. So initially it will take some time to generate, build, and Git to understand what are the files that are present. And once that analysis is done, it will actually give you the build, and you can just click the branch you are on, and it will just post it for you. So right now I'm in the master branch, and the index.html, we have seen that it is in the master branch. So I will just click master branch, and yeah, that's all. It will automatically host it. You can see that it's in green. that your site is published at TQV team, etc. Like whatever your username is .github.io. So that's where GitHub static page comes into picture. And this was the file which I had pushed. And if I visit that URL in Chrome, I can see the HTML contents here, correct? So that's how the websites work. You will host some contents of your build somewhere, and when you visit, it will make a request, and you will retrieve all the home page that is there on the website. So that's about the static hosting, and even you can choose some open source themes that are available on GitHub or third party websites like Hugo, Jekyll, and all those things are linked in the last slides. You can use that, and you can create a good portfolio for your own profile, and even you can showcase your resume kind of a template there, and you can add that to your resume, and they can look at your personal website, correct? So that's how it can be done. So next will be our exercise. Actually, before that, I'll just quickly show you how to post the GitHub page. I'll do it for the exercise one which we had done in the morning, and hopefully there is some content in HTML dot. Yeah, there is exercise one added from local machine. So I will quickly head on to settings, and I will have to scroll down and find for GitHub pages. So here it is saying currently pages are disabled. If I select master branch, GitHub pages source is saved, and it will analyze, and your site is ready to be published at the URL will be this. So I just have to select the branch where I have to host it, and it will just create a build, and it will host the page. Usually it takes couple of minutes, so let's wait for 2 to 3 minutes, and the website contents will be up in this URL. So one more thing I had added, that you can link your custom domains with the GitHub static website, right? So it's done usually here. So you will have to type your domain name that you have purchased, that is www.user.in or something like that. And then if you press save, a new file will be added to your repository called CNAME. I haven't pressed save here because it will mess up the current posting. So it will add a new file called CNAME, and it will have that link to your actual domain you have purchased. And I have linked the GitHub official documentation at the end of the slide. You can refer more for GitHub pages there. So you will have to use an A tag in the domain authority host where you have purchased the domain, like GoDaddy or any services that provide domains to buy. You will add some configurations. You can explore about that. It's very easy, and you have to just add all the GitHub remote IP addresses, and along with that, you will have to create an A tag. And GitHub documentation is very good, and you can always refer GitHub documentation for all those advanced concepts, correct? So it's saying your site is published at this particular site. So if I visit it, you can see that the line is here, and even the title is exercise one, correct? So this is actually hosted. You can visit this particular URL, and you will see the changes, correct? I will just share this URL in the chat window. You can just visit, and it's live. And let's quickly move on to the exercise. And I think the session concepts was clear. We have covered a lot of things, lot of Git advanced concepts, and let's quickly move on to exercise, and let's end the session. So this is very fun exercise, and I think if there is any doubts before moving on to exercise, you can go ahead and ask. So what is this exercise about? I will explain the problem statement now. So this exercise is about actually forking the repository already there on the TQB organization. You can see TQB. Yeah, this is the organization actually. The URL, I will just paste it in the chat window. So that's the URL you have to visit first. And then over there, you will find a repository called Git version control. You can see the last repository here, right? When you visit this organization, it will look something like this. And last repository is Git version control. So you will have to click on Git version control and then particular repository. So when you fork your repository, it will be copied to your profile as we had seen for the exercise one, right? It was forked from the another profile. And when you fork it, it will be in your profile and you will have to clone that forked repository that you just did to your local machine by git clone command. So hope I'm clear. First, you will have to visit this repository and then you will have to fork the repository and the repository will be on your profile. And then you will have to clone that repository to your local machine. Once this step is done, same as exercise one, you can add any of your previously written codes or any of your projects that you want to share along with this repository that we are creating. You can just add anything to the same repository, or else you can just write some simple txt contents also if you don't know right now. And once that is done, I have kept one more file in the Git version control. It's actually only one file right now. That is index.md file, correct? And it has Git. It's actually a markdown file. Index.md. .md is markdown file, and it has the detail with title and description. And I have added contributors, and for sample, I have added my name. You can feel free to add your name like this, and if you can see the file, it's it's minus and it's used for listing actually. You can see the bold right, sorry, bullets right there. So you will have to just go to the next line or you can just add your name here and it will be like this and like this and you will have to do that. And then after once this is done, you will have to create a pull request to the repository that is git version control. So once you make changes and once you push it to your particular system and it will ask to create a pull request. So you will have to create a pull request and I will be merging it to the git version control repository here and the changes will take place and it's actually hosted and we can see the hosting this URL. Also, one more thing, you can also host .md files, that is markdown files. The link which I have shared now is a markdown file and it's hosted. When you add and create a pull request, your name will automatically come under this. So that will be pretty good and we can have this file as hosted and others can also watch it. So I hope the flow is clear. I have made a flow chart for it. That is, we have a repository. You will have to fork it to your profile, then clone it, then add more file, then push your code to your profile, and then you will have to update that in your profile and then create a pull request. So if you have any doubts in this exercise, you can go ahead, or else we will have like 5 to 10 minutes for the exercise, and then again we'll come back and let's solve this along. If you have any doubts, please feel free to ask me. Also, if it is taking too much time to execute commands, if you are really a beginner, then what you can do is you can visit the URL I have sent, then just fork the repository, just press the fork button, and repository will be forked to your profile. And then over there itself, you have edit options, right, which we have explored, and you can just edit your files there, or you can just upload with GUI also. It's fine for now, and that should be fine. And then after that, it will tell you to create a pull request, and please click on it and then create a pull request so that it can be merged with the branch.
Yes, I have a doubt. That's all right.
Yeah, sure.
Okay, so it's about merging. So say we have a master branch. I have branched out from that branch and say I'm working on alpha release 2
Hmm.
and I have done a lot of changes and then I've sent a pull request to the master branch and now there are conflicts and I have tried to resolve them and to the best of my abilities. And then I have merged the changes. But after I have pulled my master branch and I'm trying to compile the project, it's not working. So there's something wrong with the way I merged it. So now if I want to go back and try it again, one way would be to go back to the previous version of the master branch. But my questions are, will the pull request still be there? Will the previous, like the branch that I was working on, the Alpha 2 branch, will that still be there? And in which state will that be? And like my basic question is, can I do that again if I mess up?
Okay. That's really a good question, and it usually happens when you are working in a very large project, correct? So how it works is you will have a master branch, and you have your alpha release branch, and you will have both the changes committed to Git, right? Let's say Git is keeping track of both the branches, and that's your one commit. And after that, you have executed merge commit, which is comparing the new branch and the master branch, and it has detected the conflict, correct? And then after that, you try to resolve the conflict by editor or by GitHub. And then after conflict is resolved as per your knowledge, and then later when you actually run it, some errors. Correct? That was your main question,
Yeah,
right?
that was my question. Yes.
And then after that, if you want to roll back, you will be rolling back to a stage where the previous branch, also master branch, were at a particular stage before the pull request was created and it was merged, right? So both the things will be retrieved in the same stage, and but there will not be any pull request, because even for pull request we have a commit. If you observe, while creating a pull request also on Git IDE, we had to commit something and then create a pull request. So either you can go back to that particular stage if you want to continue with the pull request, but locally, usually there is no pull request. You will be directly comparing the branch and then merging it, and automatically it will declare fault right there. So you can either go back to the pull request commit if it is there. If it is not there, you can just go back to the latest commit that you have done before merging, and both the things should be there.
Okay, that cleared up a lot. Thanks.
Okay, thank you. I think we can start the solution part. So initially the step are visiting this particular repo and forking it, then cloning the repo, and then adding more code to it, and then pushing your code to your profile, and then creating a pull request. So there are 5 steps. Let's go ahead and do it. So this is the repository, and it's on TQB Li2. So I'll be forking it to my username. I can see 2 forks already, and I will fork it. So this is forked, correct? And I had specified that we have to create a pull request by cloning this repo, and then we have to create a pull request. So I will be going back to my code editor, and I'll clear everything, and I will come back, and I am in the session 2. Now I'll say git clone. This repository is cloned, and I can just go to that particular repo. I can see index.md file here, correct? And now if I want to edit that, I can do it right here. Since my name was already there because I had given it for example, right now I will just add one more line in the above that saying learning. And one more thing, Markdown files support emojis, so you can add emojis and you can document it very well, correct? And I have added it, and I can just clear the terminal and git add, git commit -m, added, or I can say updated x.md file. I can git push, and the changes are pushed to my repository. So I can just refresh it now, and you can see that updated index.html is updated. So right now to create pull request, as I said, you can compare and analyze and then create pull request, or else just you can just click on this new pull request, and it will say is there any conflict between this, and if there is no conflict here, so I can just create a pull request, and updated index.md would be the pull request commit that we are adding, and then yeah, successfully I have created a pull request. So that's how we create pull request. And then when I come here, and there are 3 pull requests actually by different participants, and admin or whoever is maintaining this repository, open source repository, will merge those details or the created pull request here. So this was created by a participant Kalpan, and he has added a program which will add to predefined numbers and prints it, and he has also added his name in the file index.md file. So I'm the one who is monitoring it, and I will confirm the merge. And since there was no conflict, it got directly merged, and we should see the code changes. Yeah. So if we go to index.md, he has added name and yeah. And there are two pending pull requests, and let's quickly merge it. And it is by a participant Bharat. And right now we can see that there is a conflict because I have merged Kalpan's pull request, and in the same place Bharat has edited, correct? So there is a conflict and we can resolve it in the Git ID itself, correct? And then let's go ahead and make it as resolve. Let's commit the merge and in the merge, yeah. And it will check again and it will say there are no conflicts. I'm confirming the successfully. And we can actually check here live. Before it was only the example name. And if I refresh now, it's Kalpan and Bharat's, it's updated just now. So the build should rebuild and update the hosted website, correct? So it takes some time. So if I refresh now, there is only one pull request that is pending. And if I come here, we should see that it's merged, and this was the last pull request that was created by me while solving the exercise. So I will merge this also, and obviously there should be no conflicts because I edited at the top of that contributions line, so Git will understand and it will merge the changes. So finally we have merged all the pull requests that was made, and we have successfully added everything to the same file. Uh, so we can actually see the hosted page which should be updated. Uh, let's see it. And I've shared the link in the chat window. You can just go ahead and see the changes. Yeah, all the lines are here. Happy learning is also here because it took it as the same line. And contributors, it says all the names that were added. And yeah, that's about static hosting, merging, and forking the Git repository, and also contributing to the open source project like that. So that's how we contribute to open source project. The process which you had just completed now is the procedure for contributing to the open source project. So I hope this is clear. It's a very important concept uh, where you can apply all the Git concepts that we have learned in a single place right now. And let's quickly see the summary of all the things which we have learned throughout the session, even in the morning session and the current session, which is session 2, and session 1, which was in the morning. And what all cover so far, and it is pretty much right. So basically we started with introduction to Git and installation setup, and then we used GitHub, created repositories, and we saw the common commands. Also we saw about git readme.md file, which is a markdown file, and also about the GitHub student developer pack, and GitHub gist. Also, we performed an exercise to clone and push. And later in the next session, we covered branching, pull requests, and merging. And when there are merge conflicts, so how do you resolve it? And after that, we saw working with remote and collaboration. and forking, and also undoing. How do you undo things when you do some mistakes? And next, we also covered how do you host a static page on a GitHub page. And after that, right now, we just covered activity called open source project, you can say, and participants actually forked the repository, and then they created a pull request, and we have merged all the changes, and the website is also posted, it's live. So that's about the content which we have covered. And as I said, I have provided all the useful links in the PPT, and this is the so here you can find all the great documentation by Git, and even W3 docs for Git is great, and all the Git sheets, Git cheat sheet that has all the commands in brief, which you can refer. And also, if there is any doubts or if you need any guidance, step-by-step tutorials and all, GitHub has everything in their help and guides section. You can just go and take use of those articles and tutorials. So the themes for your building portfolios and all the stuff, you can choose one of the themes which are free from Hugo or Jekyll, and then start to modifying the actual theme. And this is a very useful link folder, sorry, slide, where you can refer a lot of the content that covers almost everything, correct? Um, so next, if there is any question, let's discuss about it, or else that's the end of the session.
Yeah, hi Rajesh. I have one last question.
Yeah,
Just now, I had forked from your this
yeah,
thing, right? From your repository, and so I had forgotten to add a file. Like I had made some changes in the index.md, and I had also written a Python file which I forgot to add in my push. And then later, after you merged everything, like you merged the pull request from Bharat, from yourself, and from me.
yeah.
Now, my forked repository is 6 commits behind you. So
Correct.
now, is it possible to pull the changes and then merge conflicts in my own repository in my local system, and then send a pull request to you?
Yeah, I think it is possible. What you can do is I think you will have to clone you will have to either clone the repository, and then add some remote. No, that is not the right method. Uh, yeah, maybe I think you will have to fork again, because once the tracking is lost between the actual project and your forked project, I don't think you can create a pull request, or else you can try creating a pull request from the current repository that you have forked, and if it accepts the pull request, then that should be fine.
Yeah, actually, I did create a pull request, but my main concern is when we are trying to say contribute to open source, we would
Hmm.
want to do most of the work so that our pull requests are as easily acceptable to the owners of the or the admins of the repository, right? So maybe we would want to take care of the conflicts and then just send them the file to just glance over and accept the pull request rather than them having to spend say half an hour, 45 minutes in like sorting out the conflicts.
Correct, correct, correct. I think it should work. You have already created a pull request, I can see here, and I think this is the right method. If you want to know the latest change of the open source repository, I think you will have to fork it again, or else this should be fine. Routing, I think this should be fine.
Okay, thanks.
Thank you. Thank you for attending this session. It has been a long session from morning, and hopefully you have learned something about Git and version controlling, and you can go ahead and use this concepts in your projects and hackathons, even when you go to industry, or you might just join an internship over there also. It is very useful. Git is a very powerful tool that you must know. Hope this session was helpful and you have learned something out of it. And I want to thank Li2 Technologies and Cisco Incubator for giving me this opportunity. And again, this workshop is conducted under Cisco Incubator program. Also, there are more upcoming workshops on Webex. You can visit tqb.li2.in and register and make use of the courses, right? So let's see next time then. I think this session was useful. If there is anything, you can just let me know here, or else we'll end the session.
Yeah, thanks for taking the session, man. Thanks for your time.
Thank you. Thanks a lot.
It was a really good session. Thanks.
Thank you. Okay then. Thank you. Thank you for attending. Let's end the session. Thank you. Thank you, one and all.